Well, hey everyone. Thank you so much for attending this session. I'm Brandy Freitas. I'm a senior data scientist at Precisely, which is the new name for our company after Pitney Bowes Software and Data, which is where I was before merged with SyncSort. So I wanted to just introduce myself. This is kind of a snapshot of me, my life and random interests, and sort of my path into the role that I'm in currently. So I just wanted to give a little bit of my background to start so you have more of an info on my perspective on this kind of project. I'm a relatively recent transitioner from academia to industry. My graduate research focused on physics and computational statistics. I applied machine learning techniques to protein structure analysis. So I've been in industry at Precisely for a little over 2 years now. And my role in the organization's typically been to consult with internal and external teams in data science and data related work. So I work with clients and partners to kind of help them through their data science journeys, figuring out, where they are in the life cycle of a data science or machine learning project, what they're trying to accomplish, and then offer guidance on how to approach and tackle their different analytical initiatives. So from this and from working across, a ton of different industries from, state and local government to financial crimes and compliance to retail site analytics, I've really found that a lot of the time, the main barrier to improving business outcomes with data, which is what we were all told all of this crazy amounts of data would finally help everyone to do, is that stakeholders and data practitioners don't really speak the same language, and there is a lot of confusion over what goes into a data science or a machine learning initiative, and sort of who does which piece throughout these things. So what I wanted to do today was offer, an overview of the different pieces of a data science project, how they flow into one another, where machine learning really fits in with this, and who's responsible for kind of each section of what we're doing here. And let me give a specific example of this sort of confusion from just a recent client story. So I've working recently with a retail company. I was speaking to one of the stakeholders in charge of a new initiative to streamline their supply chain by changing the way they stock inventory across the US. So she explained to me that she needed to hire a machine learning engineer who knows R and Docker, and that she needed them right away, that getting them hired was a huge priority for her in order to even start this project. And I was surprised both by the confidence in what she said she needed, as well as just the overall, as well as just the overall specifics around that kind of skill set for that kind of data professional. So, after a bit more discussion to what she was trying to do and what kind of success would mean for this project, it made much more sense to, skill up a business analyst who already had an in-depth knowledge of the retail space to get some of the initial analysis done, define the project more, explore whether it was a project even worth pursuing, rather than build an entire team all the way up to a machine learning engineer for the company. And honestly, this is really not an uncommon event. This is something that happens quite a bit with this. So what I'm hoping to do is that going through this sort of framing exercise will be helpful from both the business side and the less technical perspective, as well as the data practitioner side. So really kind of building a common, approachable language to talk about the field and the players in it, with the goal of being able to bring more data-driven projects and initiatives to fruition. So first, I'm going to define data science so that we are all kind of on the same page, right? So data science is a term that is everything related to preparing, cleansing, and analyzing the data. It's the umbrella of techniques that were used when we're trying to extract insights and information from the data, statistics, programming, advanced analytics, machine learning. It really spans everything from defining the business problem to deploying models to explaining the insights from them. So machine learning can be part of a data science project, right? But it doesn't necessarily need to be. And sometimes you just need to get trends to make more of an informed decision. So it really depends on the needs of the business, the quality of the data, and the sophistication of the team itself. So let's start with different kinds of data roles and where they typically will be, what they'll typically be expected to know and where they typically fit in to the flow of a project like this. So I think a lot of the time we tend to hear data, big data, data science, and we kind of tie the entire process to a data scientist specifically. And I really don't think this is the right way to think about this. It's also kind of how a lot of job opportunities are listed. So it's a bit of a confusing space. A person at one company might be called a data scientist, but fulfill the role of an analyst. Someone might be called an engineer, but perform the role of a data scientist. So I really want to clarify just kind of 4 fundamentally different roles and how we work with data in these roles. And all of these roles really can and should interact with each other, and some of them definitely overlap, right? So some of the skill sets that are required in one are common across them. So some of them, like a machine learning engineer or an analytically focused data scientist might also not even be needed if you're not venturing too far into predictive and prescriptive analytics for your projects. So to start with, what's an analyst? An analyst in general is going to be answering ad hoc questions from the business team, preparing dashboards to visualize how business is performing across a variety of different metrics. They're going to be, really like pulling data out of SQL databases, becoming an Excel or Tableau master, producing basic data visualizations, reporting dashboards, and they're going to know things like SQL, Tableau, or other, BI or data viz tools. Excel especially. And if you're looking at, people coming out of places like economics or things like that, you're going to see, or people that have been in the field for a long time, you're definitely going to see people with a strong SAS background. Moving on from the analyst, a data engineer is my favorite person ever in any of these projects because their role is really to make the data accessible to data analysts and data scientists in the database and make it robust and well pipelined into areas where we can pull the data and actually do something with it. Especially when we're dealing with, oh, I'm sorry, I'm seeing some, can you hear me still? Okay, great, thanks. Sorry about that, guys. Okay, so, really just, this is someone who's going to be production level coding for Python, Java, Scala. They're going to be absolute experts in SQL, Spark. They're going to need to really have a good understanding on the big data side often, depending on that. So it's really one of those kind of very, very technical sides. I see a lot of people who are really good data engineers coming out of the software engineering or computer science backgrounds. They have really, really robust coding skills. And then moving on to the data scientists, I think that these are arguably broken down into kind of 2 different types of data science or data scientists. The type A, which is focusing on kind of answering questions, why something in the company is happening, how do I improve it? They're going to be really, really interested and focused on understanding the kind of exploration of the data and the wondering about, what kind of problems can I solve and how can I fix things? They're going to be really strong with the R statistical computing language, especially if they're coming out of the academy like I am, or more frequently now Python. A pretty deep subset of Python. I would say that data scientists in general don't need to necessarily understand the entirety of all of the different ways to program in Python. I think there is a pretty niche side part that is the data science package, but and then incredibly strong with SQL, and then with a lot of knowledge and depth in computational statistics and mathematics and probability. which I think is really crucial if you're going to hire a data scientist. The type B, which I think is more commonly considered a machine learning engineer now. These guys are really developing data products using machine learning to develop production level deployable models. Customer-facing things like recommendation engines are an example of a work that a machine learning engineer would do. And a lot of engineers, a lot like the engineers from before, they need very strong coding skills in languages like Python, Java, Scala. They need to know SQL and how to deploy models across environments and in the cloud. They need to have really strong back-end engineering skills to get into this. And I think this is typically a very challenging role to fill, but a very impressive skill set. So now let's look at the overall flow of a data science project and a machine learning project in general, and where these kind of roles fit in and who's responsible for which piece. So I'd say data science is typically thought of in a cycle. There are a lot of moving parts and people involved. And if it's done well, there's a lot of checkpoints and iterations in this. So this is going to overlap a lot with the product management flow for developing a machine learning project or product as well. For those of you who asked that in the questions prior to the session, this is going to be very specific to that as well. I'd say as a manager and an executive, you don't necessarily need to understand every technical detail, but I know from a practitioner standpoint, it's really, really important for that level of person to have a good grasp of the entire process behind extracting useful insights from data. A lot goes into even a small scale project. So having a perspective on what you're asking for when you initiate these kind of projects is really, really important. So when we first start out with this, I think this is something that occasionally is not thought of as important as it really is, which I think it's absolutely critical, is what is the problem that I'm needing to tackle? What are my objectives? What am I really trying to do? Without this and a really strong understanding of this, there's really no point in continuing. You need a lot of input from a number of different people. That's very important here, especially someone who's familiar with working with data, to make sure that the goals and objectives and timelines that you set for these are even possible, right? So for my retail client example, making sure to understand what the goal and the success criteria are for the first pass at understanding what items are purchased where and with what frequency, and seeing whether this information can help the business understand whether changing the way they supply stores would even make a significant difference, or a significant enough financial difference to put in the effort is really critical. So the next step after figuring out what do you want to do and how it's going to be evaluated is data mining. So this is a process where we say, what data do I need to collect to tackle this problem? Do I need to scrape data, source it internally? Do I need to purchase data and go out to vendors? Do I have considerations like Internet of Things devices that are coming in? Do I have streaming data from point of sale systems? And also being really realistic about what's overkill for the project itself. So, do I really, really need to have all of the streaming data coming in, or am I fine with data that I have now? And for data engineers, I'd say they're asking at this point, what's the most efficient way to store and access all of this data? Do I have security concerns over who can access certain pieces of the data? Where am I going with this? And so, as a retailer, maybe I own all of my point of sale data, but I want to look into purchasing location-based demographic data or spend data to better understand my stores and the people who might be in proximity that would shop there. So this leads, to investigating vendors, evaluating the quality of the data, coordinating the delivery of the data into the correct systems. There's a lot behind kind of collecting and getting this point. So this should certainly be a team effort between, budgeting with the business side, data understanding from what the data scientists think they would be interesting to add to models, But likely the majority, I would say, of the heavy lifting on this end is going to be on the data engineer side if you have a data engineer. So once we have this, we move into the ETL side, and ETL is extract, transform, load. This is going to be primarily the job of the data engineer. Data extraction itself involves exposing all the data from all the disparate sources that you mined and collected to downstream processes, like data transformation. Data transformation in particular, we process data by handling things like missing values, fixing inconsistencies and malformed data entries, transforming them into the proper storage format or structure for the data scientists or analysts to query and analyze. And finally, data loading describes the insertion of the data into the final target database, like an operational data store, a data mart, or a data warehouse, something that's going to be easy for analysts and data scientists to work with the data directly. So I would say for this, there definitely exists data scientists that have experience and are comfortable with this kind of pipeline building. Though I would caution that this is not typically what data scientists like to do, and it's quite an undertaking when it's done well and done to be repeatable. There are also some tools out in the market that kind of attempt to democratize this process and make the critical foundational piece easier for smaller companies or teams to tackle through software or on-demand services. This does add a layer of kind of a black box to some projects, so I think it needs to be something that the team downstream who will be using the data is comfortable with, but they are definitely solutions that exist out there that are good. But for a really robust implementation, scalable architecture, I personally think that the data engineers really do kind of the yeoman's work in getting these projects onto a solid ground. So once the data is in place, where it's accessible, ready to be used, this is typically where a data engineer will pass the project off to a business analyst or a type A data scientist like myself, where we will start to go through the process of EDA or exploratory data analysis. So in this, there's a lot of questions that you're going to ask at this stage, especially from the data science perspective. So, what's interesting about this data? What are some hypotheses I can start to form? Typically, this is going to be a mix of visual and statistical exploration. So I'll pull things like summary statistics, averages, outliers, confidence intervals. I'll graph the data to see, shape and trends. It's typically pretty fast, in-depth exploration where I'm just really looking for inspiration from the data. Like, what is it that I'm going to be doing with this, and what's really striking me? This is typically handled, I would say, by data scientists, but it's increasingly accessible to analysts as new tools kind of democratize the space again. I generally caution that you can't replace years of computational statistical thinking and understanding with drag and drop EDA tools. And I think that really responsible companies that sell these kinds of tools, I think, should make what is going on in the background as transparent as possible. So we don't have, more muddying of the water. And there's a sense of like trust and explanation in the analysis that people are doing with these sorts of tools. But, I think it is really great for companies that can't invest in insanely huge data science teams or find people that are really good at this to get at least something out of it. So at this stage, I'm really looking at, what shape is my data in, or what shape my data are in. If there are trends that strike me as interesting or odd. So in my retail case, for example, I might explore the data from my loyalty program and see how complete my age and gender categories are, whether I can actually use those in my analysis. I might see whether I have an item in my point of sale data that has unusual spatial distribution across the country. I'm going to start thinking about how these data can help me better distribute products to my stores. I'm going to definitely check in right now with the business side and let them know some of the initial insights I'm getting from this piece of the process. And really getting those business insights will help me as I transition to the next phase, which is something we typically call feature engineering or feature extraction. So this is a really big piece in a machine learning project, especially because downstream, what you do here is really going to impact your machine learning models and how you bring them to production, how they run it, and what they're really going for. So, here I'm trying to get these data to work for me and help me move forward to hopefully modeling and predicting outcomes. So I'm asking questions like, what are the important features or variables in my data? This can be done using mathematical models. It's often refined by incorporating business knowledge, which I think is really critical. So, yes, I might have 10,000 columns in my data set, but which ones are really adding value to my models? Which ones are actually predictive? Which do I have a high confidence in? And which am I able to collect and verify easily? Which variables are highly correlated and should be removed, right? So there's a lot of considerations that you go into here that really help you when you're going on to a machine learning side. And here we're also looking at, can I construct more meaningful features from the raw data? So something simple as like calculating the age instead of having a date of birth, because, depending on the algorithm you're using, it's a challenging kind of variable to use. Or I might do a cluster analysis to group stores based on what sells and when. I can add a label like young families after analyzing, what a cluster contains in it. So there are a lot of unsupervised learning techniques that can be used here to add value to models later on. This is also a good stage to impute values that might be sparse or use techniques to intuit variables like gender based on name. There are lists you can buy, APIs you can ping that have names, nicknames, and sort of typical genders associated if that's important for your model. Or adding grouping labels like makeup across a number of unique items in the inventory to make it easier and more analytically robust. So this stage is really crucial, and it's going to directly influence the accuracy, the speed of the predictive model you're constructing in the next stage. Typically now, I think we are talking about a data scientist, the analytical side of the data scientists, for prototyping especially, and doing this kind of feature work. And now we're really moving on to the modeling and predicting side. So, what kind of model should I employ for this kind of data? And the question I'm going to ask, what data do I have to train this model? Like, what is it that I'm looking at? So based on the question, this can be any number of machine learning models. Maybe I'm further into my retail example and I'm trying to decide which product assortment to stock a brand new store with. I don't know anything about the store. I don't have any history on it, but I do have a lot of information about where it is and the demographics around it. I might try training like a similarity-based model, like a k-means, or an error-based model, like a support vector machine, and compare, the relative recall on my train. How can I improve my model's outcomes? How am I evaluating these models? Given new data, what is my model actually telling me? What's it predicting? So I think this is definitely a data scientist role, especially for counting on depth of understanding of what model performance means before you take off and change everything you're doing from a business perspective and investing that money into it. You really need to make sure that the team behind the models that are interpreting the results and analyzing it really have a strong understanding of what the performance means. In a setting where you need other systems to interact with your models downstream, so after you're done kind of in the experimental and prototyping, they need to be robust, production level code. This is where a machine learning engineer is coming in. So you really see engineers kind of on both sides of the data science process, getting the data to flow into the experimental pieces of the process before we get into EDA and feature engineering, right? And then when you're taking the experiment to production, machine learning engineers are going to be taking that out of the lab, essentially, right? So machine learning engineers need to design the solution architecture for applications, automate the model training, reviews, and the deployment process to ensure there's continuous deployment, especially for things like recommendation engines like you see at Spotify. These are the guys that are taking the model from the analytical data scientists, from the lab to the market. They build the pipelines to production. And then the last step here, visualization. How can I communicate my findings with key stakeholders so that they're clear and interactive? Business analysts need to be really, really good at this, as do data scientists, especially when it comes to explaining statistical models and some of the more black box techniques. I mentioned support vector machines and algorithms that they might have used. Data visualization is a really tricky field, though, mostly because it seems simple, but it could possibly, I think, be one of the hardest things to do well. And that's really because data viz combines fields like communication, psychology, statistics, art, to communicate the data in a simple and effective way. And I'd also caution, you really can't discount the prettiness for the visualization. It really needs to be visually appealing, or at the very least palatable, for people to be able to really take it and use it, and really take meaning out of your either machine learning product or your data science flow. And again, this is a cycle. So I'm asking questions at this point like, did I answer my question? Am I explaining it correctly? Did I come up with a bunch of new questions? Do I need more or different data to incorporate into this? Do I need to remove some of the data, or am I having issues? And we really begin this process again and iterate. It's also not the end for the models you've deployed, so you really need to make sure that you have a robust way of making sure they don't drift or go stale, is a way that's often termed, and that there are quality checks on the data coming in and quality checks on the data that are coming out of it. So any of the predictive data. All right, so that wraps up my session. I hope that you have gotten kind of a good base for what the roles are of people in the data space, where machine learning sits in a business outcome-oriented data science cycle, and where there are some limitations or considerations to take into account along the way. And with that, I will say thank you very much, and I will take any questions you might have. If you want to type them into the chat, I can stay a little late. I know we're right up against time, but I really appreciate it. And then to the questions I had already in the app, there is a really interesting talk from Strata London last year that I attended with Pete Skormarok, which I'm probably butchering. He did a really good job breaking down kind of how challenging it is to develop a product that requires so much experimentation and uncertainty and bringing a machine learning product to market. So any of the people that asked about that he's a really good resource for that, and I can provide that in the chat. Yeah, so this is a great question. So the question is, you listed salary values for various roles. I am reporting probably New York level for that, and those would be junior coming in. So people with a lot of experience. Well, I would say, first of all, some of those roles, like machine learning engineers, are going to be coming out, with PhDs, and they're going to be highly valued even at a junior level. But I would say, in general, those are probably January values for the US, particularly places like New York and San Francisco. And again, it depends on, where you are in the world, where those will end up. But okay, and I will leave the product management question here for you guys, which is Pete. And that was Strata London last year. Okay, do you see any roles related to change management? Slim, I'm not sure if I totally understand the question. Oh, this is okay. This is an interesting one. So, question: do you have any information on the trade-off or relationship between increasing a data or machine learning team size and performance? I think that a lot of the time this comes back to the what is a man-hour issue in like software development and software engineering. By adding, 20 more man hours, are you really going to be improving your outcomes? I think this is where having a really good data science manager comes into play to understand not how many people to staff, but who to staff and what skill sets they have, and sort of where they have gaps. So I would say, a lot of companies, like I know I mentioned Spotify for recommendation engines, they have an enormous data science team, but they have very specific roles and who is doing what and how they're interacting. And I think they're very well orchestrated. So I think in order to get an increase in performance out of an increased team size, you need to have a very, very excellent manager for that. I think that is a unusual skill set, is the data science manager. Yeah. Okay, so do you have any case studies on wins, dings, orgs made in starting up machine learning teams? Yeah, so I've definitely worked with a lot of companies that maybe 2 years ago decided that they not only wanted to start a data science team, but they thought that the only way that they were able to, or they would be able to improve business outcomes was to really push machine learning. And I've seen that kind of be demoralizing to the organization in general. And I think it kind of, if it's not, I think a lot of the time it's gone about in a way where people were very enthusiastic about starting these projects and nothing really went through. And a lot of the time, these machine learning projects, we've heard this a million times, kind of fail. And with that failure, I think you see a lot of people being very trepidatious to start a new project again. So I'm trying to think of ones I can name names for. I'm not sure if I can, but I've definitely seen a couple, especially in the retail space, that hired a bunch of people to do things like in the supply chain management side and have essentially gone to outside consulting firms that do that kind of work all the time because their in-house build really didn't work. So they had either not a lot of budget to get people that were very experienced. So they hired a lot of sort of novice data scientists and data engineers, and that resulted in them not really being able to push forward with projects. So I think it's worrisome because you see a lot of people say like, well, it's not doing what it's supposed to be doing and it's not as good as everyone thinks it is. I think you see a lot of like detraction from that. As for successes, I think that companies that work with partners who have experience, especially on the business use cases side, tend to do a lot better than those that try to build out in-house everything they're doing from scratch. All right. Trade-off between scaling the internal team versus outsourcing. Oh, I think I just said that. Yeah, it depends on kind of how your org is set up for partnering and outsourcing. For an organization that's kind of more on the sales-based side that needs data science to, let's say that they're selling data as a product and they want to prove the value for data science projects or machine learning projects that their data can provide, I think those are typically partnerships where you're really working with the partner and sharing in the profits from that. So those tend to be not easy, but relatively easy partnerships to work with. For data-driven products that your company really wants ownership of, I think it's a challenge to, I think it's a challenge to work with partners unless your partner team is very well developed. That being said, resource planning, hiring an entire data science team, getting a data science manager, and doing that, I think it's something that really needs to be investigated over the long term as to whether that's going to be helpful for you, whether that's really like where you want to go. So I think there's a lot of like kind of iteration you can go with. Yeah, so Aaron has a good point. You can always start with third-party services and then chip away at them, develop it in-house. Yeah, I think for teams, I think once you kind of start with that, you'll understand where your team is lacking experience. You can either hire or upskill within, which I'm a huge advocate for the upskilling side of this. So taking people that have been working within here and really focusing on increasing their career prospects and helping them out as well as helping yourself out. All right, guys. Great. Well, thank you guys. This is nice. You can definitely reach me on the app, and feel free to message me. I'm happy to help. And if you guys have any questions, please don't hesitate to reach out. Thanks.